This is the second video about binomial probability. On this one, we're going to kind of continue from the last one, so if you didn't watch it, go watch it. Our probability of success in that scenario, we were rolling 2 dice and we wanted to get a score higher, or a sum higher than 7. So that probability was 5/12. And we're continuing with that example. Say we have 4 rolls and we want to know the probability of getting exactly 3 that have a sum higher than 7. So one of the things we can do in our calculator, if you remember, we on the regular screen, we had a combination. So it was 4, and I go option over to probability. 4 choose 3 times, and then I needed that 5/12. I needed that to happen exactly 3 times, and then I needed the 7/12 to happen once, so I don't need parentheses on that one. And I found this value, which doesn't tell me a whole lot, but here's my decimal, so it was about 16.9%. Now the other thing, your calculator can do this for you. So when you go into menu, you can go to statistics. This is a distribution that we're looking at. We talked before about normal, but now we're looking at the binomial distribution, and we want to find that at a particular point. So we're going to use this BP, and this is a variable that we're doing on these. So then x is the number of times you want it to succeed. So we want it to get exactly 3. Our number of trials, well, we're throwing the dice 4 times. And then our probability of success is what goes here. So that is 5/12. So that'll clean up right there. And then when I hit enter, it gives me the probability of having exactly 3 sums of greater than 7 if you're rolling the dice 4 times. We can also say, well, let's say that we're going to roll the dice 9 times, I don't know, and we want to know what's the probability that we get exactly 3 that have a sum of that, or sum greater than 7. And that probability is this, about 23.9%. Let's say we want to know, we're going to roll it 9 times, and we want to know what's the probability of getting, more than 7 success. And in our scenario, a success is rolling a score higher than 7. So what we've got here is this would be more than 7. That means it's the probability of getting 8 plus the probability of getting 9. That's more than, if we're rolling it 9 times, we need to have 8 successes plus 9 successes. Or you could say 1 minus, and then we could add them all up. Probability of 0 plus the probability of 1. All the way out, keep adding to the probability of 7. And sometimes if we're doing it manually, we want to decide which of these would be easier to do. Okay? On this one, adding 2 things is a whole lot easier than subtracting, what would that be, 8? So we're going to pick this method, which would be, okay, we have 9 choose 8 times we want to succeed 8 times. We want to fail 1 time. Plus, then we have 9 choose 9, which by the way is 1. We want to succeed 9 times, and we want to fail 0 times. And I can pick this up. I can grab my calculator. Let's go back to that other screen. And I'm doing, I lost it, option over to probability. 9 choose 8 times 5/12 needs to happen 8 times, we have a 7/12 that needs to happen once, plus we want to do 9 choose 9 times 5/12. This needed to happen 9 times, and the probability, it's kind of low. The probability that you get 8 or 9 would be, 5.15 times 10 to the negative 3, so that's what you're doing is moving it 1, 2, 3. So it's a pretty low probability, but there we go. Now the calculator will also do that for you. So if we come back to menu, statistics, we go to distribution, we're doing, wrong one. We're doing binomial. We want to do this one, BCD, where it's a cumulative binomial. So it's still variable. The lower bound, we wanted 8 to be the lower one. We wanted 9 to be the upper one. We have a number, 9 trials. And then there's that same probability. That was that 5/12 probability of success. And when I hit enter, this 5.148 times 10, that looks very familiar. Okay, so the calculator will do that for you. And that's what we're going to work with on those. So there's some problems to practice, so good luck with that. Enjoy.